School like all the time. I started my math actually that's why you're that person.
Good morning. Oh, okay, folks, we're going to go ahead and get started. I just want to kind of give you an overview of what I expect from her. Obviously, I can't guarantee down to the day, but this is my expectation. The very first thing is today you're going to work with balanced equations to do mass-to-mass conversions. On Wednesday, I expect to start concentration calculations with an introduction of molarity and how we get to how we calculate molarity from solids. On Friday, my goal is to perform dilution calculations and then talk about conversions using concentration as a conversion factor. You have decided that on Monday, we are not having class, that you are on your own. So basically, that means you will be practicing this on your own. What I don't get, you know, these concepts will get practice. Then the Monday after Thanksgiving break, I expect to review going into your fourth exam on Wednesday. The other thing I expect to do is let those that may be taking the final exam know how to study for my final exam. I will do that on Monday. So again, Monday after Thanksgiving will hopefully be nothing but review and describing how to study for my final. Any questions for me? Okay. If there are no questions, then we're going to get started into today's information. Last week on Wednesday and on Friday, we focused on balancing chemical reactions. Now what I want to start out with the meaning of these balanced chemical equations. Not only did we balance these chemical equations in order, well, first of all, I should say, we balance chemical equations in order to make sure that we follow the law of mass conservation. Mass cannot be created, nor can it be destroyed. Each element has its own mass, so the number of that element on the reactant side has to be equivalent to the number of that element on the product side, so that mass is not created nor destroyed. Now, to balance those chemical equations, the only thing we were allowed to touch was the coefficients before the formula. You're not allowed to alter the formula in any way. You can only alter the coefficients that precede the formula. What I want to discuss is, what do these coefficients that we developed mean? One way to read this is that one molecule of N2 reacts with 3 molecules of H2 to make 2 molecules of ammonia. The problem with that particular variation of the meaning of this balanced chemical equation is that this meaning would indicate that we're able to manipulate one molecule at a time. However, molecules are so small that it is impossible to manipulate one molecule at a time. So this definition, while valid, is not the most useful. So instead of this definition, the definition that we will tend to use is that 1 mole of N2 reacts with 3 moles of H2 to make 2 moles of NH3. And just like before, when we start talking about moles, now we're talking about 6.022 times 10 to the 23rd of them. So we're talking about 6.022 times 10 to the 23rd molecules of nitrogen reacting with 3 times that quantity of hydrogen to make 2 times that quantity of ammonia. The use of this idea of mole is much more useful in chemistry because then we're talking about things that we can actually manipulate. So the next one, instead of me writing it out in Word format, though I can, what you're going to see me write it out in most frequently is 2 mole KClO3 is to 2 mole KCl and 3 moles of O2. Or in other words, I'm going to write it as a mole to mole ratio. Which we've used before. Where have we used it? Well, we used it in conversions. You may remember this flow chart that we started or that we actually finished. Where if I had atoms, ions, or molecules, I automatically knew I was going to use Avogadro's number as a conversion factor. If I had grams, I automatically knew I was going to use the molar mass as my conversion factor. Now, we have 2 locations to get this mole to mole ratio. The first one is the mole to mole ratio will come from the chemical formula if you are converting between a substance and an element within that substance. But the second location where that mole to mole ratio will come from is the mole to mole ratio will come from the coefficients of a balanced reaction when converting between
two substances in the reaction. So we'll start out straightforward and get more complex. How many moles of hydrogen are needed to completely react with 2 moles of nitrogen given the reaction N2 plus 3H2 goes to make 2NH3. Okay, as before, we're going to start by identifying information. We have been asked, or we have been given 2 moles of nitrogen. And we have been asked for moles of hydrogen. Because nitrogen and hydrogen are different substances, we will be using a mole to mole ratio. In this case, it's going to come from the balanced chemical equation. So according to that balanced chemical equation, 1 mole of nitrogen corresponds to 3 moles of hydrogen. We begin our calculation with what we were given, which is 2 moles of nitrogen. Nitrogen has to go, the moles of nitrogen have to go in the denominator. So the 1 mole of nitrogen is going to go in the denominator with the 2 moles of, excuse me, 3 moles of hydrogen in the numerator. The moles of nitrogen went into the denominator so that the unit and the substance canceled out, leaving moles of hydrogen, which is what we were asked to solve for. So then you complete the calculation and you get 6 moles of hydrogen. Let's take it a step further. Methane gas reacts with 2 oxygen gas to form carbon dioxide gas and 2 water liquid. What mass of water is produced by the combustion of 1.00 moles CH4? We identify what we were given, which is the 1 mole of CH4. And you identify what you need to solve for. We need to solve for mass of water. If we're talking about mass, what is the unit? Yes.
Is that from the all the way
It's just an N.
after H2O?
Oh, an L. I'm sorry, my cursive is terrible. It's a cursive L. So what unit am I solving for? If I want mass? So I need grams of water. Okay. Substances are different. So what am I going to need to use? Mole to mole. And where is this mole to mole going to come from? From the reaction, because we're talking about 2 substances in the balanced reaction. So it's 1 mole of CH4 to 2 moles of water. The next thing I see is I do have moles. That's great because I already have moles. What in the dickens? We started with moles. I already have moles. The other thing I note though is that I need grams. So I'm going to use something that'll allow me to get to grams. And if I see grams, what is my unit going to be? What is my conversion factor going to be if I see grams? Molar mass. So I have 2 hydrogens. Times 1.008. So in other words, 2.016. And I have 1 oxygen times 16.00 for a total of 16.00. It adds together to be 18.016. So it's 18.016 grams of water is 1 mole of water. Now I'm ready to do this math because I've got the units, I think. That's how it always is you think you have everything, so you go for it. My first conversion factor needs moles of methane. So I'm going to be using my mole to mole ratio. I will put the 1 mole of methane in the denominator and the 2 moles of water in the numerator. The mole of methane went in the denominator so that the unit and the substance would cancel, leaving moles of water. The next thing I need is something with moles of water, and I can't use mole to mole again. So I'm going to use the molar mass. The 1 mole of water will go in the denominator, and the 18.016 grams of water will go into the numerator. The mole of water had to go in the denominator so that the unit and the substance canceled, leaving grams of water. And when you calculate this out, well, let me do it so I can. You get 36. 36.032 grams of water. Now we have to figure out significant digits. In our first value, there were only 3 significant figures. In the mole to mole ratio, that's an infinite number of significant digits. In our molar mass, there is 5 significant digits, and the mole ratio is infinite. So the measurement with the fewest had 3, so our answer should have 3. So this would be recorded as 36.0 grams of water. Questions? Yes.
For the mole to mole ratio, how did you know it was 2 mole of H2O?
This comes back to the coefficients. 1, I can do this. 1 CH4 because there's no coefficient, and 2 water. Other questions? Let's look at another example. How many grams of magnesium nitride is needed to react with an excess amount of potassium oxide to produce 11.6 grams of magnesium oxide. The reaction is Mg3N2 plus K2O goes to form MgO plus K3 in. Folks, I'm throwing this one up here because this is going to be something that comes up commonly. In the last two problems, I gave you the balanced chemical equation. I did not give you the balanced chemical reaction this time. It is your job to make sure that the equation is balanced before you use it. So this reaction needs to be balanced before it can be used. So again, anytime you're dealing with a chemical reaction, step number one is to balance the chemical reaction, or at least to view it and say, is it balanced? Now on a test, I will say I'm try to be nice. And that is, you will have balancing separate from conversions. But on the homework, you may not have balancing separate from conversions. So step number one is always to balance the reaction. Then you can go through and say, okay, what have I been given? I have been given 11.6 grams of magnesium oxide. What have I been asked to solve for? I have been asked, what are the grams of magnesium nitride? Okay. First thing I notice is my substances are different. What conversion factor do you need if your substances are different? Mole to mole. And where does the mole to mole come from? The chemical reaction. According to this chemical reaction, 1 mole of Mg3N2 is associated with 3 moles of MgO. The next thing I notice is that I have grams. Anytime I have grams, what is my conversion factor going to be? Molar mass. So I need the molar mass of MgO. I have 1 magnesium and I have 1 oxygen. Magnesium has a mass of 24.31, oxygen a mass of 16.00. So we're talking about 40.31 grams of MgO is 1 mole of MgO. I noticed that I have grams of magnesium nitride as well. What does that mean? If I have mass of magnesium nitride, what is my conversion factor going to be? Anytime you have grams, it's the molar mass. So I need the molar mass for another compound. I have 3 magnesiums and I have 2 nitrogens. Magnesium is 24.31. Nitrogen is 14.01. Nope, that's correct. So the magnesium contributes 72.93 to the overall mass and the nitrogen 28.02 for a mass of 100.95. That is 100.95 grams of magnesium nitride is 1 mole of magnesium nitride. Now that I have my conversion factors based off of what I was given, what do I do? Solve the problem. So 11.6 grams of magnesium oxide is where I'm going to start. The first conversion factor has to have grams of magnesium oxide. So what is it? The molar mass. It's the molar mass. So I'm going to put the 40.31 grams of magnesium oxide in the denominator and the mole in the numerator. The grams were placed in the denominator so that the unit and the substance would cancel out, leaving moles of magnesium oxide. Now I got to get rid of moles of magnesium oxide. So the conversion factor that has moles of magnesium oxide is my mole to mole ratio. 3 moles of magnesium oxide will go in the denominator, while 1 mole of magnesium nitride goes in the numerator. The moles of magnesium oxide had to go in the denominator so that the unit and the substance would cancel out. Leaving moles of magnesium nitride. My last conversion factor is going to have moles of magnesium nitride in it. The moles of magnesium nitride will go in the denominator, while the mass goes in the numerator. The moles of magnesium nitride had to go in the denominator so that the unit and the substance would cancel out, and you're left with grams of magnesium nitride, which is what you were asked to solve for. $11.6 divided by 40.31 divided by 3 times 100.95 gives you an answer of 9.68345 grams Mg3N2. We have to think about significant digits. Our first number had 3 significant digits. The mole portion of a molar mass has infinite number of significant digits. For magnesium oxide, the mass portion had 4 significant digits. Mole to mole ratios have an infinite number of significant digits. The mass portion for magnesium nitride had 5 significant digits, and the mole portion had an infinite number. So the measurement with the fewest had 3. So our answer should only have 3 sig figs. And so you would record this answer as 9.68 grams of magnesium nitride. Questions? Let me give you one to work on. I'll give you the balanced chemical equation. C3H8 plus 5O2 goes to make 4H2O plus 3CO2. Out of curiosity, anybody remember the term to describe this reaction? Combustion. How many grams of water can be produced from 32 grams of propane? The answer, so you know if you got it, is 52 grams.
Carbon is 12.01. Hydrogen's 1.008. And oxygen is 16. For needing the numbers.
I did before, so that I was able to go on. And none of them are based on this week's.
I haven't calculated. Yeah. Yeah. Well, I need more nights for water too. I understand that.
I will fix that.
But that's probably right.
Yeah, I'll put those, there will be an ed puzzle for this week that needs to be, that's related to what we just did. Or no, actually it's relating to balancing. Yeah, so I'll make sure the balancing one shows up. Because that's the one that's missing.
Yeah, because I noticed that there was five, but there wasn't five on the last week's name.
Okay, so. Just to do this one real quick.
Basically, it was, let me make sure I'm on the right one, 32 grams of C3H8, 1 mole of C3H8 is 44.094 grams of C3H8. There is 1 mole of C3H8 for 4 moles of water. And then 1 mole of water has a mass of 18.016 grams of water. And when you solve it and get to the correct number of significant digits, it's 52. Note, there will be one more ed puzzle that I think somebody told me was not showing, and it should have been in this week's folder. So that ed puzzle will show up in this week's folder because it's due on Monday. So again, no, it's due on Friday. So I'll put that ed puzzle in this week's folder. So again, there's 5 of them.